Hello. In this video, we are going to go over how to solve Charles' law within chemistry. The first thing we need to recognize is that we are dealing with volumes and temperatures. The first thing we need to understand as well is that V1 is equal to our starting volume. So our first volume or starting volume. V2 is our final volume. And usually those will be in liters. It's okay if they're both in milliliters. Then we have temperature for T1, which is starting temperature. And then T2, which is our final temperature. Cool. Another thing we have to remember is that temperature is always in Kelvin, which we take Celsius plus 273 is equal to Kelvin. What we're going to do is read the problem. We're going to be given 3 out of the 4, and we're going to solve for the missing fourth. Very straightforward. So let's read. First, we have oxygen gas is at a temperature of 40 degrees Celsius when it occupies a volume of 2.3 liters. I stopped there and I realized, hey, that is my T1, that is my V1. So I write T1 equals 40 degrees, but remember, we need to convert that to Kelvin. So we're going to add 273 to 40. And what we're going to be getting is 313 Kelvin. Next, I'm going to write my V1, which is what they were associated with each other. At that temperature, I have that volume. So at 40 degrees temperature, I have 2.3 liters of volume. So that is T1 V1. We keep reading and we see to what temperature. So I don't know my T2. Not at all. I don't know it. What we need to see, finishing off the sentence, to what temperature should it raise to occupy a volume? We know that our volume is 6.5 liters. So now we're given 3 out of the 4. I rewrite my equation. V1 over T1 equals V2 over T2. Let's make that a little more clear and neater in a different color. So V1 over T1 equals V2 over T2. We are solving for T2. So what I'm going to do is multiply. What I'm going to do is, we're going to multiply T2 to the other side. This is the easiest way to do this. Multiple ways to do it though. T2 times V1 over T1 equals V2. And then now I need to get rid of my T1 and V1 because I want T2 by itself. So I'm going to multiply T1 to both sides. So we have T2 V1 equals V2 T1, then divide by my V1. And we see T2 equals V2 T1 over V1. At this point now, I can just plug and chug because I can see, all right, well, T2 is equal to V2, which we know is 6.5, times T1, which we know is 313, all over V1, which we know is 2.3. We're going to plug and chug that into my calculator. Make sure you use your parentheses accurately. I suggest doing numerator separately, then do denominator, and then divide them afterwards. I get 884.6 Kelvin. So that would be the final temperature for this problem. So let's do one more example to solidify Charles' law. So the next example we see, on a hot day, you may have noticed that potato bag chips seem to inflate, even though they have not been opened. If I have 200, so V1, we can see immediately we're told a volume. V1 is equal to 250 milliliters. T1 at a temperature, so V1 is associated with 19 degrees, but remember, we have to convert that to Kelvin, and we will get 292 Kelvin. We're going to look for V2 and T2 now. What will be the new volume? So we're looking for a V2. if the temperature of the car turned to 60 degrees. So we're looking for V2 when T2 is equal to 60. So remember, we write 60, have to convert that to Kelvin. We get 333 Kelvin. And then now let's fix up our equation. So let's do it in a different color so we can see V1 T1 equals V2 over T2. What I want is V2 by itself. So all I need to do is multiply the T2 to the other side. I get T2 times V1 over T1 equals V2. And now we plug and chug. T2 is 333. V1 is 250 all over 292. We're going to plug that into a calculator. Make sure you're careful with your parentheses. 250 all over 292. And we get approximately, oh, I'm just going to say equal. And we get 285.1 milliliters for volume of V2. So that would be the answer for the second example of Charles' law. If you have any other questions, please just let me know.